Hi there, it's Professor McDonald, and in this video I'm going to be answering this question, which reads, for a standard normal distribution, find capital P parentheses negative 1.08 less than z less than 2.75. So let's break down what we just read there. First of all, we have a normal distribution, which means it's bell-shaped. It is standard, which means it has z-score boundaries with a mean of 0 and a standard deviation of 1. Also, the notation there, P parentheses, reads probability of, which means we're looking for an area under the bell curve, since when it comes to continuous distributions, area and probability are interchangeable. So for this particular example, we're looking for the probability that a randomly selected z-score would fall between negative 1.08 and 2.75. So the sketch would look like this. And I have the shaded region there to represent the area we're looking for. And the way that we're going to find that area is by using the strategy, which I refer to as the large left area minus the small left area. They're both left areas. One is going to be larger because it comes from farther to the right. So we're going to start with 2.75 and get the area all the way to the left as far back as you could possibly go. And that's going to be an area that is too large. And if we take off this little region where the white tail is, then we'll have what's left in between. So we will find a smaller left area using the other z-score, negative 1.08, from the left and subtract that from the larger first area we find. So first we'll find the larger left area from positive 2.75, and we'll use the z-score table to do that. Now, this example has a negative z-score and a positive z-score in it, but this will work no matter what the signs are on your z-scores. Just pay attention to which table you are using for each part. So since this first example, or this first z-score, is positive 2.75, I'm going to look in the positive z-score table. So the z-scores are on the outside, the first column and the top row. So the first two digits are in the left column. So I'm going to look up 2.7 here, and I'm just going to highlight that row and keep track of it. Then I'm going to look for the column heading that has 5 as the last digit. So that's here in this column. And I'm just going to come down here and find that I get 0.9970 for my first left area. Then I'll go ahead and find the smaller left area from negative 1.08. So now I have to make sure that I use the negative z-score table and look up negative 1.08. So first, negative 1.0 is going to be this row, and then I want to match it up with the column that has 8 at the top as the last digit. So that's the second to last column here, and so I get 0.1401 for the smaller left area. Then all I have to do to find my final answer is to subtract them. So I'm just going to take my larger left area minus the smaller left area, and that is my final answer for this question. Now, we also can use Excel to find each of these two left areas. We can use norm.dis, and if I'm going too fast, make sure you pause or back up. It is a video, so you can do that. Then you're going to put in your large left area. I'm just going to refer to the cell containing it, then put in my mean of 0 and my standard deviation of 1. Just be careful here. If you're doing a similar example where it is not standard and you don't have z-score boundaries, you'll have a different mean and a different standard deviation to put in there. Then I'm also going to say true for cumulative, which will always be the case when using norm.dist. Now I'll press enter, and since I used a cell reference there, I'm able to copy this down. Otherwise, you can just type it in by hand each time by actually typing in the z-score numbers. Now notice when I subtract the larger minus the smaller, I do get an answer that usually will round to exactly the same answer you would get from the z-score tables. Sometimes the last digit might be a little off, but the way that the homework is programmed usually accepts either answer. So that's it. Thanks for watching, and I'll see you in the next video.